Physics, Chemistry, and you are watching Chem Science.
In our earlier video, we have seen introduction to the organic chemistry, that is, what is organic chemistry, what are different types of homologous series, what are hydrocarbons, etc. And in this video, we'll be learning about how to name the organic compounds. So the basics of the naming organic compounds, rules for naming the organic compounds with various examples. Now, as we know that all the organic compounds contains carbon, so the naming depends on the types of the number of carbon atoms present in the compound. So any name of the organic compound, the prefix that is starting of the name of the organic compound tells us about the number of carbon atoms present in the longest chain of the organic compound. So starting of the name is done by the number of carbon atoms present. We will learn that in detail, that how the number of carbon atom is denoted by its name starting, and the suffix, that is end part of the name of an organic compound, tells us the types of homologous series the organic compound belongs to. So a prefix and suffix together will tell us the type of organic compound. If we start with the simplest example like methane, then meth, that tells us the number of carbon atom, and ane tells us that the homologous series to which the compound belongs is alkane. Same way if we name ethanol, so the starting of the name, that is eth tells us the number of carbon atom, that is 2 carbon atoms, and nol, that is ol, tells us that the homologous series here is alcohol. So ethanol belongs to the homologous series alcohol with 2 carbon atoms. So let's understand this in detail with more examples. Now the type of homologous series we have already seen, that alkane will have the name ending ane, alkenes will have the name ending ene, alcohols will have the name ending ol, and carboxylics will have the name ending oic acid. So let's start and understand by what are the suffix and how does that indicates the name and type of organic compound. So when we say meth means and compound carrying 1 carbon atom, that is, it has only 1 carbon atom in the chain bonded to the other atoms, which may be hydrogen or other elements like alcohol, oxygen. So the example here, simplest example I'll take is the methane, as we have already seen. Methane, so methane is CH4, so 1 carbon atom, and alkane, so all carbon atom with a single bond. If the organic compound carries 2 carbon atoms, then the suffix, the starting of the name, should be eth. So there are 2 carbon atoms in the longest chain of the organic compound. Obviously, the 2 carbon atoms are bonded to the other atoms also, like hydrogen, oxygen, nitrogen, etc. But the longest chain have the maximum of 2 carbon atoms, and it starts with eth. For example, ethanol have 2 carbon atoms, so C2, other hydrogen atoms will be H5OH. Now it says ol means alcohol, so we have OH group into it. If the carbon atom have 3 carbon atoms, then the starting of the name will be prop, so 3 carbon atoms in chain bonded to other atoms, which I am not showing here. So 3 carbon atoms means the starting should be prop. Now if we take an example of carboxylic acid, then propanoic acid, that's the example for 3 carbon atoms propanoic. So here we should have 3 carbon atom total, so 2 carbon atom for the alkane chain, and carboxylic acid also carries a 3rd carbon atom. So total of 3 carbon atom gives the name propanoic acid. Bute means the organic compound carries the longest chain with 4 carbon atoms. So 4 carbon atoms in chain with each other bonded to other elements also. And here I take an example of butene, that is an alkene, butene, alkene. So butene should carry 4 carbon atoms and bonded to other hydrogen atom with a double bond. So here the molecular formula will be C4H8. So bute indicates 4 carbon atoms. Pent, so organic compound carrying 5 carbon atom will have its initial starting with the pent. So 5 carbon atoms in chain bonded to other atoms, and the simplest example of this is pentane, and the molecular formula is C5H12. All the alkane or pentane is an alkane where all the carbon atom will be having the single bonds bonded to either carbon on the one side or hydrogen remaining atoms. Hex means 6. So organic compound carrying 6 carbon atoms in chain. The longest chain should be 6, otherwise there can be more carbon in the branch, but the longest chain carrying 6 carbon atoms is having the name starting with hex. Now let's take another example, say hexanol. So if the starting is hex, it contains 6 carbon atoms, and ol means it should have the OH group also and the remaining hydrogen atoms, that is 13 hydrogen atoms, 1 oxygen and 1 more hydrogen. Hep means carbon atom carrying 7, organic compounds carrying 7 carbon atoms, and so longest chain should have 7 carbon atoms. So here are the 7 carbon atoms. Obviously the others are the elements bonded to the carbon atom. Also there are other bonds here. And let's take a simplest example of heptene. These are more easier. So C7H14 is heptene, where it's an alkene carrying 7 carbon atoms. At IGCSE level, you may find in your books still hexane or hexene only, that is the organic compound carrying 6 carbon atoms only, but I am giving you here some additional, and I am not drawing here the remaining carbon atoms of C8 onwards, giving a longer chains. Let's take an example. Here maybe an octane, simplest octane, that is an alkane carrying 8 carbon atoms. So here the formula will be C8H18. This is the alkane with 8 carbon atoms. Non means 9 carbon atoms. So nonane is again an alkane carrying 9 carbon atoms, and so the formula is C9H20. Dec means organic compound carrying 10 carbon atoms. So there are simplest example of decane, also decene, also decanol also. Let's write an decane here with C10H22, but you can take any such examples of other homologous series also, and so the formula might change, but the number of carbon atoms in total will not change. Let's understand one more point, that the number of carbon atom denoted here are the carbon atoms present in the longest chain of the organic compound. Now if there are branches, there are substitutions having carbon, that is not considered here. The longest chain should have this number, so the name is given accordingly. Let's go ahead with the naming in detail little more, and we call that as an IUPAC naming system. Now IUPAC naming system is an international standard naming system of the organic compound. So let's understand what is this IUPAC. IUPAC stands for International Union of Pure and Applied Chemistry, and this organization have made some rules for naming the organic compound. So let's see those rules. And the first one is find and name the longest continuous carbon chain. So if there is a chain of carbon organic compound which may have substitutions, branches, so we have to choose the chain which is having the highest number of carbon atom, and that is the name which decides the organic compound. So here first look for the longest continuous chain of carbon atom and name it. Identify and name the groups attached to this chain. Identify and name, that is what kind of group, that is an homologous series it is, and also identify the groups, that is the substituent group or the chain which is attached to the longest chain. That is important. So find out what are the different substituents, branches attached to the longest chain, or what's the functional group present to it, and then name those groups. And next, number the chain in such a way that the substituent group carries the lowest number. So we have to number the chain in such a way that the substituent group, that is the branch, gets the smallest number. So we have to start the numbering at the side with the substituent group. Now this we'll understand with the help of some examples later on. The next is say that number and name each substituent group also appropriately. That is that what group is present in the substituent group, whether it's a methyl group, ethyl group, or any alcohol or some other functional group which is present as a substituent group. So we need to identify them, name them, and also number it, and then finally decide the name of the organic compound. Let's understand all these points with the help of examples. When it comes to naming the substituent group, we need to understand one point, that when an hydrogen atom is removed from an alkane chain, then the group is called alkyl group. Now if suppose an alkyl group is there in the substituent group, then obviously that group is CH3 group, because here it's bonded to some other carbon. So here one hydrogen is less compared to its alkane group, that is methane. One hydrogen is less, so we can't call that as methane, but we call this group as methyl group when it is present as a substituent in one of the organic compound. So such groups where one hydrogen atom is less and is present as a substituent group, we call that as an alkyl group. Example: methyl, ethyl, propyl, such groups. So the name indicates how many number of carbon atom is present in the alkyl group, and one hydrogen atom is less into it because it is present as a substituent group. So let's start naming by the simplest example. Now here it's a simple alkane chain because all the carbon carries the single bond, carbon bonded to another carbon, and there is no other substituent group other than the hydrogen atoms. And how many carbon atoms does this have? 4 carbon atoms. So the name should start with bute, and as this is an alkane homologous series, so ending will be butane. So this is our simplest butane organic compound. Now this organic compound, the next one also is butane, because here is the longest chain. The longest chain carries the 4 carbon atom, but here there is a substituent group bonded to one of the carbon atom which carries only 1 carbon atom. So the substituent group is methyl group because it carries 1 carbon atom, and as we have discussed earlier, with 1 hydrogen atom less, so it is methyl. Now we need to name a number. Now we have already decided the longest chain is bute. So the name should definitely have bute, and as it is the simplest alkane homologous series, so butane should definitely be there. But then there is a substituent group, methyl group. We need to name and number it. Name is methyl, now number it. As we have already seen in one of our rule of IUPAC naming system, that number the chain closest from the substituent group, from the end which is closest to the substituent group. So if we number from here 1, 2, 3 and 4, so the substituent group carries the number 3. But if we start numbering from the other side, the first carbon atom, second carbon atom, third and the fourth carbon atom, then the second carbon atom carries the methyl group. Now this is the lowest number which can this substituent group obtain. Substituent group carries the lowest number 2 here. When we had started numbering from the other end, we had received the number 3 on the substituent group. That is not the smallest number. So 2 is the correct number. So now number the substituent group, that is 2 dash methyl. So we have numbered and named the substituent group and then named the longest chain with its name of the homologous series. So 2-methyl butane is the name of this organic compound. Now here is another example. Look for the longest chain and name it. So let's see, if we go straightways, we have 4 carbon atoms. If we go this way, then too we have 4 carbon atoms, and if we go here this way, then also the continuous longest chain have the 4 carbon atoms. So we can go either way, but the name should definitely have butane, number carrying 4 carbon atoms, and the homologous series is alkane, as all the carbon atom have single bond bonded to other carbon and hydrogen atoms only. So it's butane. Now name and find the substituent groups. Here there are 2 substituent group. One is this one and the other on the other side of the chain. Now the thing is that both the group carries only 1 carbon atom. So both the groups are methyl group. Now if we name it and number it, from this end we have to start numbering, that is the end of the carbon which is closest to the substituent group. So the second carbon atom carries both the substituent groups of methyl group. So if both the substituent group carries the number 2, then we need to number it twice, 2 and 2, 1 for one of the substituent group. So 2, 2, and then we will write dimethyl, because there are 2 methyl groups. So 2,2-dimethyl butane is the name of this organic compound. I repeat here, there are 2 methyl groups in the substituent group. So we have named this as dimethyl. Now the number given to the number of carbon atom to which this substituent group is bonded is the second carbon atom. Both the groups are bonded to the second carbon atom only, so we are numbered it twice. 2,2-dimethyl butane. The next example here is the structure. Now have a look and find out the longest carbon chain. Here we might think that the longest carbon chain is this one with 4 carbon atom, but actually the longest carbon chain is this one with the 5 carbon atoms. So here is the longest carbon chain. So obviously the name should have pentane, because the longest carbon chain is 5 carbon atom. Okay, so if we look at this and think that it is the longest chain with 4 carbon atom, then we might think that the substituent group is this one carrying 2 carbon atom, and so our name might change because the substituent group has now the ethyl group, and one of the substituent group is methyl group. So our name might be having ethyl methyl pentane, but no, the number of carbon atom carrying the longest chain is 5, and so this group is not a substituent group, but it is a part of the longest chain. Okay, so once we have decided that the longest carbon chain is pentane with 5 carbon atom, then obviously one of the substituent group is this one and the other is shown here. Now both the substituent group again have only one carbon atom, so again there are two methyl groups, so we will name it as a dimethyl group. Now number this. So if we carry number from one end, it's 1, 2, and the third carbon atom carries this methyl group. If we number it from the other side, 1, 2 and 3, then 2, we have both the substituent group on the same carbon atom with third carbon atom. So again we'll number it twice as 3, 3 dimethyl pentane. We need to number both the groups separately, because if it's not on the same carbon atom, then one of the number will change. It may be 2, 3 dimethyl pentane. Here both the methyl group is on the same carbon atom, so it's 3, 3 dimethyl pentane. Now let's take another example which have a double bond into its compound. So now there is one C double bond C group. So the homologous series is alkene, and so name ending will be ene. Now what is the longest carbon chain? 4 carbon present in the longest chain. So bute, and the simplest name is butene. The name of this alkene is butene. Another example similar, but now the double bond has shifted. Now count the carbon atom on which the double bond is present. So if we count from this side, is the second carbon atom carrying the double bond. If we count from the other side, again the second carbon atom carries the double bond. So here the longest chain is having 4 carbon atoms, so bute, and the double bond is on the second carbon atom. So here the ene will be numbered. Ene means the carbon-carbon double bond. So ene will be numbered. So here we'll number ene with 2. So bute 2 ene is the name of this carbon atom. So here on the first example we can also name this as bute 1 ene. Bute 1 ene can also be named to the first example here on this page. So bute 1 ene and bute 2 ene, the only difference is that the position of the double bond is different. Another example here, again an ene butene, the longest carbon chain is this way with 4 carbon atom, or if we go the other way, then also there are 4 carbon atom. So let's go straight. 4 carbon atom carrying the double bond. So here again butene is there, and the second carbon atom carries the double bond. So bute 2 ene is the name. Now there is one more substituent group present carrying the first 1 carbon atom. So methyl group. Now this methyl group also has to be numbered. Methyl group is present on the second carbon atom. So 2-methyl bute 2 ene is the name, full name of this organic compound. Here are the examples of 2 alcohols, because the functional group here is OH. Here also there is OH. So the name ending will be ol because it's an alcohol. Now the longest chain carries 3 carbon atoms. So propanol. Propanol is the name. Propanol. Written it fully, propanol. Propanol. Now next example also carries the longest chain with 3 carbon atoms, but now the position of alcohol has changed. Number it from this side, one side, the second carbon atom carries the alcohol group. If you number on the other side, then also the second carbon atom carries the alcohol group. So we can name this as prop for 3 carbon atoms and ol on the second position. So prop 2 ol. That's the name of this organic compound. So even the position of the functional group may change, and so the position of the functional group should also be numbered, as we have already seen in alkenes. ene is numbered because the position of double bond has changed. Here the position of alcohol is changed, OS group is changed, so we will number the whole part of the name, and the prefix will again show the number of carbon atoms present in the naming system. Let's see some more examples in the next video.